Why are protons and neutrons in a nucleus so stubborn you can't pull them apart? But you also can't easily mash them through each other. In the energy filament theory, the strong interaction isn't a mysterious glue. It's a strict rule about tension gaps. If you try to open a tiny crack between tightly bound pieces, the tension C refuses to leave that gap exposed and rushes to stitch it closed. Instead of treating quarks as little balls swapping glue and particles, picture each quark as a tiny loop of filament buried in a fabric, dragging a sharply tilted thread through it. A single loop would shred the fabric around it, so nature only allows 3 of them to join into a triangle of tension bridges, where each awkward direction is balanced by the other 2. That triangle is what you call a proton or a neutron. When you grab 2 quarks and try to pull them apart, you're really stretching one of those bridges into a long, thin slit in the fabric. The question isn't, is there enough force to pull them back? It's that the medium simply won't tolerate a naked slit. The cheapest fix is to rewrite the stitching nearby. That overstretched bridge snaps into shorter ones, forming extra triangles, and from the outside it looks like you pulled so hard you created new particles. It feels like an insanely stiff rubber band. But what you've hit is the fabric ray triangulating itself into more stable clumps instead of letting the gap grow. Zoom out to 2 nucleons sitting side by side. They don't really see smooth spheres. They feel whether their outer stitching can share extra tension triangles. At a sweet spot in distance, a few shared bridges make the overall pattern smoother. So they attract. That's the short-range pull. Push them too close, and the shared bridges start fighting over the same bit of fabric, twisting the local pattern into something ugly. Then it's cheaper for the medium to shove them apart, which shows up as a steep repulsive core. Move them farther away, and the bridges can't reach at all, so the strong force fades fast. In this picture, can't pull nucleons apart, can't crush them together isn't magic glue. It's the tension C enforcing one simple rule at tiny scales: no open cuts. Only closed, well-stitched patterns, even if that means turning your pull or your push into an explosion of new particles instead of letting the fabric tear. Tap follow, share it on New Physics, Clear Universe.